I wanted to go over a few more loop concepts. Loops are pretty important and we've got to get proficient with them, so we're going to start out slowly and build to more complexity throughout the rest of the course. But in the assignments for Chapter 6, you were asked to write a loop that counts up from 0 to 5 and puts each number on a different line. Now, while loops and for loops for the most part are interchangeable. So I'm going to first do it as a for loop. I'm going to start my loop counter at 0 with this declaration and initialization at one time right here. Then here's my Boolean condition that will control how many times the loop executes. As long as this is a true statement, as long as the value in I is less than or equal to 5, this loop will continue to run. And once I gets to 6, it will stop. And then finally, this tells me, well, each time it runs, how much do you want me to bump up or change the value in I each time this thing runs, so that eventually it will stop and get to 6. Well, every time it runs, I just want it to bump the counter up by 1, so that I'm going 0, 1, 2, 3, 4, 5. I'm running 6 times in order to get my 6 numbers to print out. And then to print them out, I literally put the value in I. That's what's going to change and go from 0 to 1 to 2 to 3 and so on, because I'm starting it at 0, and every time this thing runs, I add 1 to it. So if I look at my output, I have my 0, 1, 2, 3, 4, 5 printed out just like I expect. And then here is the comparable version in a while loop. Notice I must declare the variable x that controls the loop. I could have used I, actually. So let's use I. We can talk about that in a second. Why can I use I again when I declared it up here? Well, this declaration of I only takes place when the loop is executing and running, and I is destroyed and completely wiped from memory after this last code executes in the loop. After the last time when I is 5, I becomes 6, the loop stops, and when this line of code here fires off, I has already been destroyed. So I doesn't exist anymore, so I am free to declare it and use it for my loop counter for the while loop, so I don't get the compile error that says, hey, you already declared it, because it's gone. Now here I do declare it, I eat up the memory, and it exists after the while loop is done because it's declared outside of the while loop. There's nothing about the while loop that destroys the counter variable. That is specific to a for loop only. So what that means is after the for loop, before I've declared it again, I cannot reference I outside of the for loop. It doesn't exist, it's been destroyed, and it's going to tell me I doesn't exist. That is specific to a for loop. When I declare it for the while loop, I can reference it after the while loop. It still exists, has not been destroyed. So if I know for a fact that I only want I to exist while the loop runs and I don't need to reference it anywhere else, I can declare it like this in the for loop. So anyway, I've got my two outputs. They're the same thing. The other thing I want to mention is I see a lot of people doing this. They declare I up here. They come into the for loop and then they set it equal to 0 and run it. That is acceptable as far as the compiler is concerned. It will allow it. Notice now I have a problem because I'm using it for the while loop. It's already declared. The compiler will allow it, your code can run and all of that, but that's not considered acceptable practice for a for loop. And you might lose points on the AP exam for doing that. So I strongly encourage you to use it in this manner. So if I know that I need that loop counter to exist after the loop, for example, if I want to write a program where I am doing an average, right, and I want to keep track of how many numbers so that I can do the average calculation outside of the loop, here I have a problem. say I had a number, say I have sum, and say in here I'm adding up 0 plus 1 plus 2 plus 3 plus 4 plus 5. So I'm going to use I to keep my running total, to accumulate my total. But at the end, I is 6. 0, 1, 2, 3, 4, 5, 6. So that's kind of a problem because I really had... No, that would work. Sorry, my mind's not thinking. I have 6 numbers, 0, 1, 2, 3, 4, 5, 6, or 5. That's 6 numbers. I is 6 at the end of the loop. So I want to use that for my average. Well, I is destroyed. It doesn't exist. That's a problem. So to get around that in the for loop, I have to say something like this. I have to keep track of how many times it runs, and I've got to do this little whole extra step, which is kind of redundant, right? I've got I, but yet I can't reference it outside the loop, but I want to do an average. So for the average, although you can do it with a for loop, you're a little better off on that one to go ahead and use a while loop. Because what I can do with the while loop is I can say, here's my sum, accumulate my sum, then I can come down here and I can do my average. And now I don't run into that issue that I did with the for loop. So while I can do the average with the for loop, I'm better off to really do it with a while loop in this sense. All right, so now we have one of the problems asked us to count down. Instead of counting up, let's count down. And let me clear up some of my errors here. Now, I can still use a for loop to count down, but what I do is I say, well, I want to start at the high number. I want to start at 10, right? And I want to count down, so I'm going to go 10, 9, 8, 7, 6. So each time I want to subtract 1 from I each time the loop runs. So I'll go from 10 to 9 to 8, 7. Then I just have to flip my Boolean expression because I want the loop to run as long as I is greater than or equal to 0. When it gets to -1, I want it to stop. And let's say, just for fun, I want this to print on one line instead of on separate lines. I can do something like that. So now I'm going to run and I'm going to get my 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I can do the same thing with the while loop. I'm going to start at 10. I'm going to loop as long as I'm greater than or equal to 0. I'm going to subtract 1 from y each time. From I rather, and then I'm going to just print everything out. So now I've got, of course I did those on separate lines, same type of thing. The other thing I want to point out is that you have a couple of options on your little expression here. I can say loop as long as I is greater than or equal to 0. So I'll go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and then I will become -1 and I'll stop. Or I can say as long as I is greater than -1. Those are saying the same thing. It's two different ways to say the same thing. I can loop until I'm greater than or equal to 0, or I can loop until I'm greater, as long as I'm greater than -1. So just be aware, you can always, there's usually two ways to do it, just like I demonstrated, to do these Booleans on while and for loops. Alright, so now let's say we're going to count up from 1 to 10, but we want to count by twos. I can do that right there. And now I will count up by 2s. I could count by 3s, by 5s, by whatever I want to do right there. I can also say I equals plus equals 2. That's just another shorthand way for doing that. I can do the same thing with the while loop. And now I'm going to count by my 2s. Oh, because I started with 1, duh. Let me start with 0. So I got my odds, now I'm getting my evens. If I wanted to not print the 0, I could start with 2 and go 2, 4, 6, 8, 10, and so on. Again, here I can say less than or equal to 10, or I could say less than 11, right? Those are pretty much comparable. They do the same thing, accomplish the same goal, stopping the loop at the same point. So I've shown you how to count up by more than 1 at a time. I've shown you how to count down. I've shown you how to change your Boolean expressions. I've showed you a better way to do the average with a while loop, although you can do it with the for loop. I've talked about how for the for loop, that loop counter variable is destroyed as soon as the loop is done executing, whereas with the while loop, because we're actually basically just doing a simple variable declaration, to the compiler it's no different than any other variable. It doesn't know it's specifically the loop counter. It persists or still lives after the loop ends. So now I want to do the factorial assignment where I take a number and I find the factorial, so that means I multiply that number by every positive non-zero number that is less than it. So I multiply 5 times 4 times 3 times 2 times 1. If I were doing the factorial of 3, it would be 3 times 2 times 1. So on this one, I could hard code the number here that I'm doing the factorial of, but if I want to change it, I want to do the factorial of 5 and then of 3 and then of 6. If I put it in a variable, that gives me a little more flexibility and it's fewer chances for error where I have to go through the code and change it. So I'm going to find the factorial of 5, and notice I can use a variable here in the Boolean expression. I also need a variable to hold the multiplication result as I loop each time. So this is like an accumulator. Notice I don't start it with 0, right? Because if I start with 0, 0 times anything is 0 and I'll always get 0. So in this case I have to think, what's a better number to default that to, and it's 1, because it'll correctly do the math from there. So here's my little counter I. I is going to go from 1 to 2 to 3 to 4 to 5. When it gets to 6, the loop will stop. I'm adding 1 to I each time so I don't skip any numbers and I get all my totals correct. I'm going to loop as long as I is 1 through 5, and then I'm just going to do the multiplication. Take the value and hold and multiply it times I. So it'll go to 1, and then it'll be a 2, and then it'll be a 6, and then it'll be, the next number, and so on. And then after the loop is done, I don't want to print out all the intermediate results. I just want to print out the final factorial. So I put the print line outside of the loop. And I get my 120. Now I can also do the same thing with a while loop. I can say my num is equal to 5. I can leverage off of that up here. I don't have to redeclare it. Then I've got my I, which is my counter variable, equal to 1. Not quite sure what I had wrong. I thought I just retyped it here, and then now it's taking a line. So anyway, so I'm going to set up I to be my loop counter, and I can do that because this I has been destroyed when the for loop ended. I'm going to keep my num, which is 5.